I'm Bharat Acharya. Welcome to a new lecture of C programming. So today we're doing paper solutions of VTU University Module 2. This is August 2022 paper, last year's paper. Students of this year have their exam in October. This is the prime time where you should be studying and focusing on preparing for this exam. Also, in the previous lecture where we did module 1, I have told you the importance of learning programming right from the first semester. Alright, when you go for your interview, when you sit for the placement, that whole purpose of doing engineering, they're going to ask you a lot of theory questions, they'll ask you some numericals here and there, blah, jazz. But most importantly, what is certain is they're going to ask you questions based on programming. How complex they are depending on which company you're applying for, but programming is something every engineering student ought to know in today's world. Are you clear? Now, instead of trying to learn this at the end, during fourth year, during placement, and struggling with it along with all the other backlog that you are doing already, do it at the time it's supposed to be done. Programming is a skill. You acquire it over time and you become better at it the more you practice. So the earlier you start, the more time you're giving yourself to practice, so that by the time when it really matters, when you sit for the interview, when you apply for that GATE exam, all of this is relevant for that too, as well as all the competitive exams, BRC, ISRO, etc. You are already good at it. You don't want to put all that serious pressure in the last year and try to scrape through all of this without really gaining the knowledge of it and without equipping yourself with this tool which engineering students are supposed to have. Alright? Focus on programming right from Sem 1. Now, we had seen question number 1. So, in this paper, there are 100 marks. First of all, why did I choose this paper? I ran this whole thing in my community where I asked students from all over India to give their question papers of last year, of C programming, of course. And I evaluated all of them. And this is the one I've chosen because it has a bunch of all important questions. Now, just hear these questions. For roots of a quadratic equation. Palindrome, check whether a number is a palindrome. Factorial using Fibonacci, using recursion. Fibonacci series using recursion. Binary search, selection sort. Come on, haven't you heard? But these are all the important questions that you hear all the time. Arrays, structures, unions, pointers, they're all there. GCD, LCM. It's amazing how they squeezed and fit all the important questions in one single paper. This is like a crash course of C programming. If you know all of these questions, you are set for your exam. Whether you're from any university, they're all important for you. And if you are from VTU, my dear friend, this is super important for you. Like, it's a given, it's an open secret in engineering. Ask any senior if you want. Since you're in first year, you got to rely on seniors. Knowing your last year's question paper is your biggest asset when you go for an exam. Alright? I'm very clear about this. I've been teaching these subjects, not just C, all of these subjects that are listed below, since the past 22-23 years. So this is experience telling you. You need to know your last year's paper for sure. Around 25, 30, 40 marks are directly repeated from the previous paper. Another 25 to 30 marks are indirectly repeated, where the question is pretty much the same, just a few words twisted here and there, probably one feature here and there changed, but practically the same question. So what are you understanding? 50, 55 to 60 marks of your paper, which is going to be there in October, will come from this whole discussion. I'm not revealing some hidden importance. This is a fact. This is how it works. Are you clear? So knowing your solutions to every question of last year's paper is super important. Yes, these are important. So there can't be options in this. Alright? I'm going to show you solution to each and every question. That's what you should do as a sincere student. Don't choose options in this also. Are you clear? All of these are important. And I've already given you the number. More than half your paper will directly or indirectly come from this whole discussion. Now, last week lecture, we did module 1, which had question number 1 and 2 and its subtypes. So there are 10 questions divided into 5 modules. Each module has 2 questions, obviously. So there was module 1, which contained question number 1 and 2. Today, from this paper, I've written the paper code 21PSP1323. This is the paper code for VTU. But like I said, this applies to all the students learning C, not just from their college point of view. Whether you're sitting for BRC, ISRO, or GATE, or any kind of competitive exam, C is the same for all of them. All of these questions are relevant to you and they're all important questions. Now, let's go ahead. So, this is module 2 for today's lecture, which contains question number 3 and 4. And of course, there are ABC subtypes as well. Now, question number 3A, it's a 10-mark full-size question. It's a super popular program. Write a program to find the roots of a quadratic equation. Come on, what is the quadratic equation? Tell me. Yeah, this is 8th standard mathematics. ax squared plus bx plus c. Do you know why it's called a quadratic equation? You may not know, you can still write the whole program and get away with it. But you should know what you're learning. So, quadratic comes from this square. If the square wasn't there, if it's like y is equal to mx plus c, there's just x, there's no x squared. That is the equation of a line. So that's called a linear equation. Using that equation, you make a line. Using this equation, you make a square, a quad. Hence the name quadratic. It's the square that makes it a quadratic equation. If there's a cube, then it's a cubic equation using which you can create a cube. Anyway, it's just knowledge. Now, you want to find the roots of this quadratic equation. What does that mean? You want to find the value of x. Now, why did I say values? Because there is x squared, so there's always two possible values of x. So, the roots of a quadratic equation, come on, give me the expression. X is minus b plus or minus square root of b square minus 4ac upon 2a. Yeah, you're not looking there, right? Look at me. Again. X is minus b plus or minus square root of b square minus 4ac upon 2a. That means the two possible roots come from this, plus or minus. So writing them separately, minus b plus square root of b square minus 4ac upon 2a minus b minus square root of b square minus 4ac upon 2a. Now, this is the issue. We are taking square root of this. First of all, let's call this a single character instead of always saying b square minus 4ac. Let's call it d, where d is the discriminant, which is b square minus 4ac. So I've not changed anything. I've just given a different name, a simpler name. So everything now depends upon this d. If d is positive, you can find its square root. But if d is negative, you can still find its square root, not directly. Then it's an imaginary number. And that means the roots become complex roots. That means there are various conditions that happen over here. The moment you hear the word condition, what do you understand? As a programmer, come on, this is not a geometry lecture or a mathematics lecture. This is a programming lecture. Yeah, stop getting distracted and focus. As a programmer, what do you understand? First thing you'll do is ask the user to give the values of A, B, C. You know how to do a printf and a scanf. Printf, enter A, scanf, capture A. Similarly B, similarly C. Once you got A, B, C, you'll calculate D. What is D? B square minus 4AC. Please tell me you know how to do B square minus 4AC. Come on, yes or no? How do you do? B square is B into B minus, in brackets, 4 into A into C. Tell me, did you understand this? So it is B multiplied by B minus 4 multiplied by A minus multiplied by C. It's a single line statement. I'm sure everybody watching this can write this statement, correct? With that, you got your value of D. Now, you got to evaluate D, which means if you understand, if, else. Do you understand why if, else? There are three possibilities of D. D could be 0, D could be positive, D could be negative. So it's if D is equal to 0. Come on, say it. Else. If D is greater than 0, else. Which means D is less than 0, because if it's not equal to 0, not greater than 0. Yeah. See, you become a programmer. Not when you get your degree, not when you get some certificate. Even in our course, we issue a certificate, but getting that certificate doesn't mean you become a programmer. You become a programmer when you start thinking like one. The moment you see an expression, the moment you see a problem, you try to think, how do I write a program to solve it? And that's a nature that gets acquired by practice. So that's what I said. The earlier you learn programming, the more you practice, the better you get. It's as simple as that. There's no rocket science to it. It's just a habit that you acquire by practicing. Anyway, the thinking like a programmer. So yeah, so these are the three possible cases. If D is equal to 0, this is how you write the expression in C, you know that, right? So if D is equal to 0, what happens? Come on. If D is equal to 0, what happens? The square root of D doesn't matter because it's 0, so it's 0. That means this doesn't matter. That means there's no question of adding this or subtracting this when this itself is 0. That means this 2a simply is minus b upon 2a, and this is also minus b upon 2a, which means there is only one root. There is only one root, both the roots are equal, so there is only one root and it's real roots. There is nothing imaginary over here. So if d is 0, it's the simplest case. All cases are simple. This is the simplest. If d is greater than 0, that means it's a positive number. That means the square root is easily possible. The roots will be different because this is a valid quantity. So minus b plus square root of d upon 2a minus b minus square root of d, the whole thing upon 2a. Are you clear? So two different roots and they are real roots. All cool. If d is less than 0, then they are imaginary complex roots, because if d is less than 0, that means it's a negative number. Square root of 25 is phi. Square root of minus 25 is phi I. 5 into square root of minus 1, which means there is an imaginary component in this statement. So this will become square root of, you can't do square root of d, so you'll do square root of minus d. I'll show you that. Basically, you'll get complex roots. What will you get? Complex. Why? Say again, because d is negative. So you're trying to find a square root of a negative number, which you can't. You'll find the square root of its positive counterpart and multiply it with I, because I is square root of minus 1. Correct? So I'll show you how to do it. So you'll get still two different roots. Why? Because it will still be some quantity. So it will be minus b plus that quantity upon 2a, minus b minus that quantity upon 2a. Are you clear? So let me break it down and make it more simple for you. There are three possible cases. If d is 0, the roots are real and they're equal, and it's simply minus b upon 2a. How did I get that? I know you've forgotten. Don't need to go 10 seconds back. Look here, I've done it for you. For your reference, I've put that statement again. Minus b plus minus square root of d, the whole thing upon 2a. Okay, this is whole thing upon 2a. So, since d is 0, this factor is eliminated. So, there's no question of plus minus. It's basically minus b upon 2a. Now, you got it? Yes? Happy? So, that is if d is 0. Now, if d is greater than 0, come on, answer. What will be x1? Come on, say the statement. Say the statement. Minus b plus square root. Yes, there is a command by the name square root, sqrt. In bracket, you write what you want square root. You want square root of d. You already have calculated d. So, minus b plus square root of d, the whole thing upon 2a. And x2 will be minus b minus square root of d, the whole thing upon 2a. Minus b plus square root of d, the whole thing upon 2a. Minus b minus square root of d, the whole thing upon 2a. Are you clear? These are proper C statements. This is the statement you'll be writing in your program. Just a semicolon at the end. These are proper C statements. Did you understand? So, this is when your roots are, when d is positive and your roots are real. Now, the third one, when d is less than 0, it is negative. This is the solution. Don't get scared. First thing you have to tell yourself is, I am not going to be scared. If the top 10% of the class finds this easy, why is the remaining 90% always copying assignments? Because they are not trying. At the end of the day, you all the same kind of people in the same class with fairly the same IQ. Someone will have a higher IQ in one subject, someone in the other subject, but overall it's the same. Like I said, it's 22 years of teaching experience. You teach the same subject or the same lecture, the same topic to a class of 200 people. Not all 200 get it at the same time. But who finally gets it? The ones who try. You may take a little more time. Some may take, even 5 fingers are not the same. Some may take maximum time, but you'll still get it if you try. The only ones who don't get it are the ones who don't try, either because they just don't have the attitude to try, or they just get too scared. Don't get scared. There is nothing simple or difficult over here. It's very simple, straightforward. Now, when d is less than 0, it is a negative number. I say again, what is square root of 25? 5. Simple. Plus minus 5. What is square root of minus 25? Now, to do square root of minus 25, you can't do directly square root of minus 25 because it's minus 25 is a negative number. So, you do square root of 25 multiplied by square root of minus 1. And that minus 1 is basically, square root of minus 1 is basically I. So, this I takes care of that square root of minus 1. So, the I is gone. Now, what you have is a real part and an imaginary part. Both of these are basically values. How do you calculate them? Look at this equation, okay? Full focus over here. I can split the denominator on both sides by simply writing minus b upon 2a plus minus square root of d upon 2a. Tell me, did you understand? So that minus b upon 2a is your real part. So please tell me, is this real part clear? Minus b upon 2a, absolutely clear? Plus or minus the imaginary part. Now in the imaginary part, I've already got I. I is basically square root of minus 1, which means over here, what will you get? Square root of, not of d, square root of minus d. I wanted square root of d, but d is negative. So I'm getting square root of minus d multiplied by square root of minus 1, which is I. Understood? So I'm going to get square root of minus d. Are you clear? Square root of minus d upon 2a. That upon 2a will always be there. So upon 2a is always there. This is square root of, not of d, square root of minus d, because I'm already putting an I over here, which is square root of minus 1. So my square root of minus 36 basically becomes square root of 36 multiplied by I. Tell me, did you understand? Because I can't calculate square root of minus 36. So I calculate square root of minus of d, which means square root of 36 multiplied by I. So all that will happen is, here you calculating square root of d, here you will calculate square root of minus d. For you, it's just writing a minus. D is already calculated. So when you write square root in the bracket, you will just be writing minus. Now if you can answer these three statements without looking on that side of the screen, I will be very happy. If I'm doing it in the class, I know I'm looking into the eyes of every student. The one who cheats, I pick them up directly. Not because I'm trying to scare them, because at the end of the day, I want you to learn it. So I want you to answer, but please don't answer by memory. We are not trying to memorize here. Answer from here, from your mind. Keep the basic equation in your mind, minus b plus minus square root of discriminant upon 2a. Come on, start. If discriminant is 0, the square root doesn't matter, the plus minus doesn't matter. There's only one root, that is minus b upon 2a. Clear? If discriminant is positive, the roots are real, it's just the statements. Tell me the statements, don't look there. Minus b plus square root of d upon 2a, minus b minus square root of d upon 2a. Correct? Now, if d is less than 0, d is negative. Come on, answer. You will have a real part. Don't look there, please, no cheating. Real part and an imaginary part. The real part will be minus b upon 2a. Done? The imaginary part will be square root of d, no, square root of minus d upon 2a. And your roots are real part plus imaginary part into I, real part minus imaginary part into I. Clear? Yes? Can you tell me the whole algorithm? Come on. First thing, declare what are the variables you'll need. A, B, C, the coefficients, x1, x2, your final results, your roots. D, the discriminant, and in that last case, you have a real part and an imaginary part. Are you clear? So you need to declare them as well. All of these, keep in mind, will be declared as what? Integers? No, you're doing division, you're doing square root. You have to declare them as floats, not as integers. Are you clear? When you do square root of 16 is 4. Plus minus, okay, keep that plus minus aside. 4. Square root of 25 is 5. Square root of all the numbers between 16 and 25 are fractions between 4 and 5. So 4.1, 4.2, 4.3, etc. So how can you get them if you declare them as integers? For all of them, you'll either get the square root as 4 or as 5. Are you clear? You don't want that. So basically, you got to declare everything in this program as a float. Did you understand? Now, so declare A, B, C, x1, x2, discriminant, real part and imaginary part. You can name the variables what you want. I like to name the variables, the full names, whatever you want. Now, the only thing you'll accept from the user are A, B, and C, telling the user to enter the equation. That is A, B, and C. Once you get A, B, C from the user, immediately calculate D. How will you calculate? B square minus 4AC. That is B into B minus 4 into A into C. Once you calculate D, you'll have if, else if, else. If D is 0, we've already discussed. If D is greater than 0, that is positive, already discussed. Else, the negative part, already discussed. Correct? So based on that, all cases of D you'll evaluate, x1, x2 you'll calculate for all the cases and you'll display the result. Pro tip, don't forget to include math.h. You are doing square root. Square root is not a standard function of C unless you include math.h. That's a header file. For students who've learned microprocessors from me, the moment you include math.h, you get all the powers of the math coprocessor. What are the chip number? 𝗕𝗵𝗿𝘁. Remember, it had floating point format, single precision, double precision, etc. So all the powers of the microprocessor come into your program when you do math.h, when you include that. Anyway, I'm just relating the subjects because I teach not just a superficial C or higher level program, I also teach assembly level and machine level where you go inside the processor. So there are many students of mine who joined me second year, third year, learned higher subjects from me, and now they realize it's placement time, we need to know programming properly, so they come back to learn C programming. So even for those, just trying to bridge the gap, just relating the subjects. Anyway, let's go ahead. If you're in first year, you will eventually learn all these subjects, but in due course of time. Now, this was the whole algorithm. Now we're going to write the program. As always, I'm not just going to copy paste the program and throw it on the screen. I will type it on VS Code line by line. When I'm typing it, I will take full participation from you. It will be like as if you are typing it. It's just that you are saying and I'm typing for you. Are you clear? Once we do the whole program, we'll run it, we'll practice it, we'll test it for all cases, positive, negative, zero, all cases of D. Are you clear? Now, just before you go ahead, before I change my screen, just to tell you what else is coming in the lecture after this. This is going to be a whole program, by the way. This is how your result screen will look like. I've told you, you have to have absolute control over your output. Your output has to look beautiful for the examiner and for your interview. When you do your placements, when you show your body of work, it should look appealing. Today, everything is UI, UX. All the apps that we use are the ones which we find super comfortable to work with, and so on. So it's a very important asset for a programmer to have tremendous control over the output. And in our course of C programming, I've taught you that in the very first lecture. Your first thing that you should have is a good command over printf. Anyway, so that's your C programming. Always write the name of the author who has written the program. Here it's me. Or respect for your teacher. Many students, even in their programs, write my name. That's how you've been taught. Anyway, the title of the program, asking the user enter the coefficients A, B, C. So the user will enter any kind of coefficients over here, and your program will calculate the roots x1 and x2. In this case, this is a case where the roots are complex. So there's a real part and an imaginary part and an I. So this and this. Of course, we'll test it for all possible cases. And this is my prompt. You can keep your prompt whatever you want to. That also I've shown you. Don't keep those really bad looking prompts where the whole path, directory, folder and all. Come on, you can't even control your output. Anyway, and all this is very simple. You just have to have the will to do it. Like keeping your table clean is very simple as long as you're willing to do it. Now, like I said, what is coming after this? In this lecture, not the whole paper, I'm talking about this particular lecture. Explain switch case, then explain while, do while, check for palindrome, explain break and continue. All this is a part of this very lecture itself. Apart from that, in this whole session that we are doing of solving this question paper, like I said, like I promised, already we got some important programs, plus there's selection sort, binary search, I think I forgot telling that, factorial, Fibonacci series, GCD, LCM, addition of complex numbers. So this is a program where we had complex numbers. Another program asked in the paper, add complex numbers using structures. Using struct, you know what's a struct in C program, right? And then finding some mean and deviation using pointers. So a whole bunch of interesting questions. These are all programs, plus there are theory questions also. Alright, now this whole lecture along with the entire course of C programming and all the various courses that I teach is available on my website, bharatacharyaeducation.com. You want to learn to become a professional, you want to learn the subjects thoroughly, come to my website. The fee for any course is 1499. Select the course you want to learn. This of course is there in C programming. If you're preparing for GATE C and COA, both of these are absolutely essential for you. Both of them carry a lot of weightage in the GATE paper. Anyway, or any kind of government entrance exams. And today ISRO and BRC are top of the list. So is IS exams. Anyway, coming back. Plus, you may have all of these in your syllabus depending on which semester you are in. Sometimes students need to take multiple courses. For that, we've also made bundles. Apart from individual courses, you can select bundles. There are lots of bundles. As you scroll, you'll see on my website. So when you take two courses together, instead of paying 3,000, you end up paying only 2,000. You get a straight 1,000 rupee discount when you take two courses. When you take a bundle of 3 courses, you get a straight 2,000 rupee discount. Plus, there are VIP packs which combine all the courses at a very low fee, depending on the duration you need them for. By default, all courses are for 6 months. You can watch the videos as many times as you like. You get a certification, of course. You get PDF, VIVA notes, practical, all the kinds of notes, materials that you need. You don't need to go through any other book. Watch all the videos. In the course of C programming, apart from this whole paper solution, there are 30 more videos where I have taught the entire subject, starting from basics, control over printf, scanf, the most basic thing a programmer needs to know, then working with variables, integers, floating point, characters, if, else if, for, while, do while, all kinds of looping, arrays, 1D array, 2D array, matrix multiplication, another super important question, you see it all the time. Structures, unions, you'll see unions in this paper also, and the whole work. Pointers. I've even gone and made linked lists, and everything that we've done is with real world practical examples, because what's the point of learning something if you can't apply it to real world knowledge? And I'm not teaching you something vague, I'm teaching you programming. This is what runs the world. I've taken examples of cricket match score. When you see a cricket match, you see the scoreboard, you can create that whole scoreboard by yourself by programming, and not just dead values. You can accept values from the user, which is what happens. There's somebody, the scorekeeper, they keep entering all the scores one by one, they're just typing it, and the program adds the tally to the batsman, adds the tally to the bowler, and then creates the final scorecard. Or that marks the tally, that marks the mark sheet. I've shown you programs with mark sheet and various real world. You take your mom's salary slip, you can reproduce it with all the taxes and all the all the program that we had done, where you get all the benefits, the basic salary, the dearness allowance, the traveling allowance, and all the taxes that are cut, and then you get your final salary. You can reproduce that by your program. You take someone's balance sheet, account sheet, you can do all of that, and this is what you need to do. You don't just solve college programs. Yes, you have to solve college programs, which is what we do, but apart from that, you take any real world situation, you go to a restaurant, you had a good meal, take the bill, just carry it home. Try to reproduce it by your own C program, where you have your basic products, then add the taxes, then subtract whatever discounts you give, apply a coupon code, get the final value. Practice. This is how you will get better at programming. And the more real world examples you take, the more you'll make it interesting for yourself. As it becomes interesting, you will do it more. Are you clear? And you get better. So it's a cycle that you get into it. You just have to start it. And I'm here to give you that push. Hope to see you there on my website. Wish you all the best. Do well. We are going ahead. Alright, so let's do this on our VS Code website, the whole program.